So this is Unit 4 notes, Lesson 4 notes, and we want to talk about principles of experimental design, and just keep in mind that if you design or set up some experiment to find out some stuff, if the experiment isn't designed well, then the stuff you figure out or find out might be BS. Might not have much faith in that. If you don't do things right, then how can you rely on what comes out? So here are some ideas inside of designing experiments. There's this idea of comparing two things. We want to make sure that we're using a design that compares two or more treatments. It could be like pill A and pill B, which one helps us the most, something like that. We need to make sure that the groups we are comparing don't differ too much, so you can't have before the experiment begins, or bias can result. So it would be a bias study if we're comparing two pills, and one of them one of the groups we pick for pill A is all females, and the other group is all males. Well, then how can we tell if our all males group does really well with pill B? How do we know pill B is what helped them? Maybe we need to split them up so there are random males and females in each group, right? All right, so randomization process, it must be, I need to say that some of this stuff doesn't make a lot of sense until you get to the actual drawings, and then it will be much better. So the drawings tell us a lot more. So we want to make sure that we're using a design. Okay, we did that already. Randomization. It must be incorporated either in the selection process of experimental units. But this isn't normal because we have informed consent, or the distribution of experimental units into the treatment and control groups. Whew, what the heck does that mean? Well, it doesn't make a lot of sense until you actually just see the picture. So please just fill in the blank, and when we get to the pictures, then ask questions if you have them. Okay? We can only, so basically, we either randomly select our groups in the beginning. That's called part of the randomization thing. Or also we can, when we decide who gets the pill A and who gets the pill B, we don't just say, okay, automatically group A, you're getting pill A, group B, you're getting pill B. We might, randomly assign pill A for group A and pill B for group B. Just as a random thing, we don't actually physically go out and say this is what's happening. So we want to randomly do it. We can only compare when the groups are as similar as possible before the treatment is applied. Randomization produces groups of experimental units we expect to be similar in all respects. Therefore, before treatment is applied, similar before all treatment is applied. Therefore, measured differences must be due to either treatment or by chance of random assignment. Okay, again, meaningless. Control, there's a control group that's treated the same. This should make some sense. That's treated the same as the treatment group. So the control group has the placebo, the treatment group doesn't, but they don't know it. You didn't tell anybody's getting any placebos. So you treat them all the same, but does not receive the experimental units in this section should not know, like I just said, they shouldn't know. Experimental units are the people, okay, that we're testing, for example. So can call them experimental units. It's kind of impersonal to call people experimental units, but you can also call them subjects of the experiment, okay? So it can be people, could be an animal study, right? The subjects could be animals. The control group is our baseline. of our experimental group has only one thing changed: the explanatory variable, the 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 pill, the placebo, or whatever it is. This reduces variability in the response variable. So, again, doesn't have much meaning for you right now. Replication kind of means that we have enough people to do the experiment. In statistics, that's what it means. Even though we have a control group and we're giving a placebo to half of them and the other half are getting the real thing or whatever, still we're going to have some variability in our results. Not everything is going to be pointing one way or another. It's going to be a wide variance. It can be, yeah, some natural variance. I would say design experimental studies. Identify a sample. That's always our first step. Who's our sample? So we have a population, all people in the United States. Our sample, females under 20 years old. Could be a sample of a subset of all those people. We randomly assign the subjects. We identify the treatments. Again, it'll make more sense when I show you the picture and the practical problem. And this one should make sense anyway. We compare results at the end of the experiment. What worked, what didn't, or how good did this work compared to that. So here it is. Let me delete this page for you to help you sift through it a little bit better. Clear page. And I can clear that page too. Clear page. Okay. So medical professionals in obstetrics, where pregnant ladies are waiting to have their babies, want to study how different brands of prenatal vitamins may impact iron levels. So we're studying iron levels. That's the variable we want to study, of expecting mothers throughout their pregnancy. So 9 months of pregnancy, 36 weeks, what typical. So the mothers are going to get some vitamins, prenatal vitamins before the baby's born. They're going to get some different vitamins, and we're going to study which vitamins are better, which vitamins help their iron levels to become better, right, in their blood. The study follows a sample of 50. That's a pretty important piece. Expecting women from 4 weeks to their delivery to 36 weeks. 5 different brands of medicine are important. Okay. A control group is not allowed. Why? Darn good question. Control group would be like you were saying, okay, we've got, say, 6 groups or whatever, and we'll have one group is going to have vitamin A, one group is vitamin B, C, D, and one group is going to have a placebo, but we're not going to tell anybody. So you tell all these women, do you want to be part of a study where you get vitamins? Because you can't tell anybody there's a placebo. And they're like, yeah, I want to be part of a vitamin study. And then these women think they're taking, one group is thinking they're taking vitamins, but they're not. So maybe something happens and their iron is really low because they don't take any pills, and something could happen, maybe medically. You know, they think they're taking vitamins. You can't do that to them. That's unethical. Okay, unethical. So you can't do that. Design a completely randomized experiment. So randomized experiment. So that's what we're looking at here, randomization. So we're getting a random experiment. So the first thing is we've got a sample. What's our sample? Sample from all pregnant women in the world. We're taking a little chunk of them. Pregnant women, and that's our group, and we're dividing them up because we have 1, 2, 3, 4, 5 different kinds of pills. So we could have pill Rainbow Light. I'll call it RL. What was the next one? Rainbow Light, Nature Made. I'll call it Nature Made. We have Mega Food. We have Ritual vitamins. These are brand names. And Nordic Naturals. That's what they told us they are. For this experiment, a control group is not... Okay, so we don't have any other groups. We got those 5 groups. So it looks like from those 5 groups, we're going to have 50. So we have 10 girls, 10 ladies. 10 ladies will give each vitamin, right? Each group of 10 gets a different vitamin. And then we kind of want to know, we kind of want to look at, from all of these, we want to analyze the results, like what helped, what didn't, so we can okay, we'd have to make sure that we randomly picked 10 women for each of those subgroups. We couldn't just say, okay, you 10 that are hanging out over here in this corner, because maybe they're all friends and they do things the same way and eat the same foods. You don't want to do that. You want to randomly pick 10, maybe assign one of those numbers 0 through 49. Remember how we did that on the calculator? Rand int 0 to 49, and then we're picking 10. And we would do that the first time to get the first 10. Then we'd have fewer people to pick from, so we'd have to do it differently after that. Okay, that's on the calculator. So,